Let's explore Apache Iceberg. It is a modern table format specifically designed for handling very large analytic datasets. This format enables efficient, atomicity, consistency, isolation, durability transactions, and improved scalability. Here are some reasons to consider Apache Iceberg. First, it supports atomicity, consistency, isolation, durability transactions, ensuring reliable data updates. It is also optimized for handling very large analytic datasets in distributed environments. Next, it provides schema evolution without needing to rewrite the entire data. Finally, it allows for time travel queries using version tables. This table summarizes key features of Apache Iceberg. The table format uses immutable metadata layers to ensure consistency and scalability. It supports atomicity, consistency, isolation, durability transactions, enabling multi-writer concurrency with atomic commits. It provides schema evolution, allowing you to add, drop, or rename columns without rewriting the entire data. Finally, it incorporates hidden partitioning for seamless query optimization. Iceberg's architecture separates data files from metadata, maintaining metadata layers for snapshots, manifests, and schema. This separation enables reliable and scalable analytics on very large datasets. Here is an example of how to define an Iceberg table using Python. First, create an Iceberg table schema. In this example, we are importing table schema field types from the Iceberg library. The schema is defined with an optional integer field called ID and an optional string field called data. Then a table is created using table.create with database name my_database and table name my_table. Let's review the key components of Iceberg. Manifest files are lists of data files and metadata used for snapshot tracking. Snapshots are immutable views of the table state at a specific point in time. Metadata files store the schema, partition specifications, and table properties. Here's an example of how to query an Iceberg table using PySpark. We import Spark session from PySpark.sql. After that, we create a Spark session using Spark session.builder.getterCreate. Then we create a data frame by reading the Iceberg table and loading data using the format Iceberg and providing database name my_database and table name my_table. Finally, we are printing the data frame using df.show. In summary, Apache Iceberg provides a powerful table format designed for big analytic datasets. It enables reliable atomicity, consistency, isolation, durability transactions, and schema evolution. It also supports time travel and snapshot isolation for maintaining data consistency. Finally, it is designed to scale for very large data in distributed environments. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.